Hi there, I'm Olivier Bloch. I'm a senior program manager in the Azure IoT team, and you're watching a quick demo of some of the cool things that are happening on the Azure IoT client libraries, and you will learn how to connect a device to Azure services. So Azure IoT is a team that is mandated that works at delivering services, tools, and toys for you to be able to connect these devices to Azure and to make the most out of the data that these billions of Internet of Things devices will be producing or are already producing right now. So the Azure IoT team is part of a broader team, and what we're focusing on is delivering these set of services. And you hear services like analytics, like machine learning, like data ingestion, like data visualization, and they're all part of that analytics and IoT family of services. The one I'm going to focus on mostly is IoT Hub, which is a new service we just announced at AzureCon in public preview, and it's part of a broader suite called the Azure IoT Suite that you can use for implementing these end-to-end IoT solutions. In terms of getting some more context and details about the Azure IoT Suite and the IoT Hub service, there are a couple of other videos you can check out from my colleagues Steve and Elio. The first one is an introduction to the IoT Suite, and you will learn how you can bundle together all these IoT-related services to build these end-to-end solutions, build your own smart thermostat, build your own industrial automation controller system, and so forth. The IoT Hub, which is one of these data ingestion and device management services as part of the IoT Suite, is introduced by Elio, and you can learn much more than in my actual session. In this session today, I'm going to focus on the connection of devices. You will have two types of devices, basically. The ones that are connected to the internet and have an IP address and can talk with these IP protocols, and the ones that don't, the ones that actually you will have to connect through what we call a field gateway. The Azure IoT Hub client libraries or SDKs will actually allow you to do both. We're talking about getting that data from these devices in a secure way so that then you can do something out of it. You will see that when we want to connect IP-capable devices, we can go directly into IoT Hub. Eventually, if you're using a protocol that is not supported, we have a structure called a Cloud Protocol Gateway that allows you to adapt to the IoT Hub supported protocols. And then you have the code for the field gateway. For now, you don't have it in public preview, but we definitely want to work on that as well. So the challenges that you might be facing or that people are facing when it comes to connecting devices to the cloud are very common and not just like proper to the Azure backend or cloud. You have several areas that as a device developer you might be struggling with or you will face issues with. And this is what we're trying to solve and help you with the Azure IoT Hub service and the Azure IoT Suite offer. The first type of problems you'll be facing is the communication protocols. Devices might not support all the existing protocols. You might have a preference. You might have a choice of a protocol because of some other dependencies. And you want to be able to have different devices talking different protocols, not only talk to each other, but also to talk back to the cloud in an easier, common way. Another one is obviously the platform specificities. When you build devices, you have a specific OS, you have a specific set of drivers, you have a specific language to develop your apps, and all of that makes it more complex for you to connect to a cloud backend because you will have to find all the libraries, the source code, and so on here and there, aggregate all of that, adapt all of that. That's a lot of work. Security and confidentiality of the data are things that are very important as well. And you might not want to recode all the cryptography, all the encrypting of the data. You might not want to reinvent the wheel in that area. And this is something that we want to help you with. Device identification, we're talking about billions of devices that will or are already connected to the Internet of Things. And so you want to make sure that you're getting the data from a device you know, and that you're talking back to that device that actually has been identified. If you want to have an alert sent to a specific device, as I'm going to show in a minute, you obviously don't want to send the alert in the wrong room or in the wrong device, so you definitely want to make sure that your device is identified correctly. Another very important aspect is command and control. How do you, from a cloud application, control these devices, send notifications without having to, once again, use a specific protocol or whatnot? And I mentioned that already a little, but more importantly, you might need to have some other device in between your endpoint, your leaf, your sensor device, and your backend, which is called a gateway, because that tiny device that is in the field might not have an IP address, might not be connected directly to the internet. So these are all the problems, the issues that we're trying to solve, bringing the IoT client SDKs and libraries. And you will see that we have plenty actually in these SDKs. We support various protocols. AMQPS, HTTPS, we'll also have the support for MQTT, and hopefully more coming soon. And the idea is for you to not have to care about what's going on under the hood. You just are at the level of creating a message, sending a message, receiving a notification on the device, which is pretty straightforward, and you'll see the code in a minute about that. We want to support the actual platforms that are used in the industry. So Linux, RTOS, Embed, Node.js, and obviously Windows. But all these platforms are out there, are used to build IoT solutions at various levels, and we want to support most of them. Last but not least, languages. You as a developer might have a preference, or you might have a context that forces you to use a specific language, or you have eventually existing code you want to reuse. And so we started with C language, which is a portable language that goes on all these tiny devices we're talking about. We also have a C# set of libraries and SDKs. We also support JavaScript and Java. All that code that you're going to see in a second is all open source, so you can go check it out on GitHub on that repository of ours called the Azure IoT Suite SDKs. And in there you will see a lot of things like C, C#, Java, Node that I just mentioned. You will see also tools. I'm going to go into details in a second. And these libraries are actually source code for all these SDKs, but you can also check out the samples. And for you to realize what we're talking about today in terms of the simplicity to connect the device to Azure IoT, let me show you rapidly the JavaScript sample. This sample here allows me to have a device connected to an instance of Azure IoT Hub, send a message, and receive a notification back from Azure IoT Hub. So it's very basic, kind of a hello world type of application. And what you can see is that I'm just like doing a requires, means I'm actually stating I have a dependency on a couple of libraries. The IoT Hub is the SDK library. The IoT Hub HTTPS, obviously, is for using the HTTPS protocol for communicating. I define the connection string that you have as part of the IoT Hub instance, and I will not go into details on how to create the IoT Hub, as you can see that in Elio's session, but imagine you have that IoT Hub instance deployed, and you can get per each of the devices that you register on the IoT Hub, you can have that connection string that will actually uniquely identify your device and allow you to have that back and forth communication. And then the principle is to create a message, create what we call a client instance, and which is an instance of that IoT Hub object. And then it's as simple as calling a send event function and send the text message here. Obviously, we're sending a raw message here. If you want to kind of build up a bit more structure around that, you can use JSON or your favorite way of structuring data. Behind that, you have that receive function that aims at receiving a notification from the IoT Hub. So you've seen code here rapidly. I'm going to dive into C code in a second, but just before, I want to highlight the fact that we have also tools and helpers in these SDKs in the form of source code again. The first one, which is very interesting, I'm going to describe in details in my demo, is what we call a serializer. That serializer helps you put data in a format that is readable for a human. And as a matter of fact, from a cloud service eventually. So we're going to put a message and various communication strings into JSON formats. And that serializer library makes it super simple. You'll see in a second how you can declare a schema for your device data and how you can upload device data in a more formatted way, and how you will also be able to process the actions and notifications from the IoT Hub into your device code. The other tool very interesting I'm going to use in that demo is called Device Explorer. It's not meant for being used in production, but it's a very useful debugging and demo and evaluation tool that puts a UI to the IoT Hub instance, meaning that I can connect to an IoT Hub instance. I can add devices to my list of devices registry. I can monitor device data. I can send notifications back to a device. Very, very useful for debugging and development processes. And you'll see also another tool I'm using, and I mentioned it here as part of a plethora of other services and tools, which is called the embed tools. And we are able to package a library and code into what's named like a embed library that you can then ingest into the embed development tool to then flash your device. Seems a bit complicated, but you'll see it's fairly simple. Last but not least, the samples. We have tons of source code samples in there, and you'll see one of them in a second. I invite you to go navigate and check out all these samples. Let me dive now into code. What I want to do right now is I want to connect an embed device. Embed is a family of devices that are very tiny and that respond to some sort of a abstraction layer for the hardware. And we have a tool online called the Embed Compiler that I'm going to use to generate a binary for a little Freescale embed board that I have here, which is the FRDM64F. And this one has something like 256 kilobytes of RAM, which is tiny, which is big in the embedded world, but tiny in our case. I have prepared a project for my device here, getting some of the libraries I'm going to use in my code in the project. And you can see I have, let me zoom in a little. You have this project called Azure Con Demo. It has the embed library down there. It has an embed RTOS because this little tiny board runs that OS called RTOS, which is a real-time OS, tiny one. I've got Ethernet support because I'm going to connect to the internet directly. I've got support for a couple of sensors. One is a temperature sensor. The other one is a LED and display sensor. I'm going to display information on that tiny LCD display on that device. And I also have an NTP client. I want to get the right time from the internet. You'll see also two other libraries, one called Proton C Embed and the other one called TLS CYA SSL. These two libraries are provided by the Azure IoT team, and they're a modified version of existing open source projects. And they are aimed at offering support for the AMQP protocol, which we're using in our case, meaning that you don't have to redevelop your own protocol underneath. The one thing I'm missing here is the actual code for managing all the sensor data, sending up, and so forth. I'm going to add that code into this project. And this code is part of the samples. I here have a clone of the repository for the SDKs. And under C, we have the serializer tool, and in there, samples. And I have a temp sensor anomaly sample for embed. Works also on Windows. These samples have been developed using C and C++. They're portable, so you can build them based on the same source code for the various platforms. This main file here is basically the one thing that you're interested in. It imports the various libraries I just mentioned, and you can see them, Ethernet, the various sensors, and so forth. It will initialize what I mentioned earlier, which is the schema for the data that will be sent from the device up to the IoT Hub. And in order to do that, we have that serializer tool or library that we're using to declare data format. Here we have a first field, which is called object name and will be a string. A second one will be object type, it will be a string. And you will see like this data appear all the way down to the temperature data and when I'm going to monitor the data sent from the device into IoT Hub. What I can also do in the schema for the device is declare the commands that this device supports, the notifications that the IoT Hub instance will be able to send back to that device. So the device notifies himself, hey, I'm here, and here is the commands that I support. And as will be in plain text or JSON format, so that you can actually understand what the device supports. Pretty useful, you'll see in a lot of scenarios. One thing I had to do here to adapt the code to my actual configuration, meaning my actual instance of IoT Hub, was to insert a connection string. In order to get that connection string, I'm using the tool called Device Explorer. That little tool, once again, is meant for development, for debugging. I was able to connect to that existing instance, and in the management tab of that tool, I was able to list the existing devices. The very first time, obviously, you had to create a new device. I would have hit create. You would have created unique keys that are allowing me to have a secure connection back to my backend, to my IoT Hub. So here I have this connection string that I copied from the tool. I injected that into the code. And I also injected the device ID, which is the unique name that will be displayed here and there for that device. The next thing I want to show you in that code is the main function. If you're a C developer or C++ developer, you'll be familiar with that. And the idea is like things are happening in there. This is where you initialize things. This is where you start the very threads. And in our case here, we are initializing the Ethernet connection. We are creating a thread that will be in charge of maintaining the state machine in good shape, and will be blinking the lights, will be getting the temperature information from the sensor and so forth. And the next thing we're doing here after initializing that background task is initializing the IoT Hub connection. And once again, as I've shown you in the JavaScript sample here, we're talking about a couple of calls. The first one is actually creating the IoT Hub client instance from the connection string, which is the setting we're passing. Once I have that IoT Hub client instance, what I'm doing is I'm creating a model, what I'm calling the model instance, which is based on that schema, data schema definition that I set up at the beginning of the code. The idea here is that I'm declaring the device capabilities in that step. And I'm preparing the callbacks for the notifications, as simple as one call for one function. And then I'm sending my first message. And the first message is about, hey, who I am and what can I do? So I basically use the serializer to put into JSON format, the name of the device and the various capabilities of that device. And then with a single call, which is send message, once again, single call, you prepare things, you prepare a message, and you send it. I'm able to communicate with my IoT Hub. And as I said, I set up some callbacks so that when a notification comes from IoT Hub, I can do something about it. What I'm going to do right now is make sure that I'm connected using my tool here. And I will look at my list of devices, and then I will set up my tool to monitor what's going on the device. I now need to compile a code and deploy that to my device. So in my sample here, I have a tool called build sample. And what I need to do is just run that batch file. And it generates the binary for that embed board that I need to upload on my embed compiler tool online. So I'm back to that embed compiler tool online, and I will be able to import that library that was generated from our sample. I will go to the upload tab. What the tool is doing right now is actually listing all the online libraries that are available on that tool. So I could be able to just import one of them. Here in my case, I know exactly what I want, which is my code. It's been generated here as a zip file. And I will just hit import to make it appear in my Azure Con demo project. So here I have all the libraries I imported before. Support for the hardware, support for Ethernet, and the support for IoT Hub, plus the bare code of that main function that will connect to the device, to the sensors, connect to IoT Hub, send messages. Next step is obviously to compile a binary. That tool is online. You don't have anything to install when you work with the embed tools, and it dumps a bunch of warnings, which is fine. We're doing C development. And here I have a binary file that has been downloaded from the website, compiled from the embed tool. Let me now go here on my downloads folder, and you see that binary just generated a second ago. And the next step for me is to connect my device. And I see a new folder appearing, which is the actual device folder, and I will be able to flash the device by just doing drag and drop. So as far as now, these are all instructions you can find on the embed website for the Freescale board. Pretty straightforward communication over serial USB, and downloaded that file. The device will reboot and will start my program. So if I go back to my device manager tool, I'll be able to see that device appearing up there and starting sending data. So that device just declared itself. It says, hey, I'm here. I am an alarm device, and that's part of the code that runs on the device itself. My device ID is that. And the commands I support are the following. And so it will support an alarm threshold alert and another one which is called alarm anomaly. And once it's done that, and it's sending regularly that telemetry data, so I mentioned I have a background task getting data from the sensor, and I have that main task, which is actually getting that data and sending it to IoT Hub on a second basis, right? So I see the temperature data coming here. I have pretty cold fingers. I might not be able to make it move, but you get the idea. Yes, it does move up a little, or down actually. And you see the data here will change on my monitor and will show a new set of data. So that's the way you send telemetry data from the device. Now what I want to do is I want to validate the fact that I can send notifications back from a cloud service into the device. I'm using the Device Explorer tool. I could do that with code. There's an SDK for services to talk to devices connected to IoT Hub. But here what I'm doing very simply is that basically I'm setting up that JSON message based on the format that the device declared to be supported. And I'm just sending it to the device itself. What's going to happen is that the device will receive that notification and will react to it. And the reaction to that is actually to display the alert on the screen and to make that little LED blink. Now, let me do that again so that you can see it. Sending the message again, and boom, instantly I've got that device receiving notification from the cloud that's been triggered by a service or an application of mine. So you've seen here very simply how I can connect a device, which is in that case developed with C language, to IoT Hubs using the IoT Hub SDK. And the one place I actually invite you to go is to our developer website on ak.ms/Azure IoT Dev, where you will learn a lot more about the various languages, the various platforms supported. You can try the Azure IoT Hub for free as part of the evaluation of Azure. You also have the possibility to go all the way up to a certain number of devices if you're a maker and want to try out and play around with IoT Hub. I invite you to learn more about the Azure IoT Suite, watching the session from Steve's at AzureCon. You can find on the same site you find this one. And also another very interesting one, which is checking out the Microsoft Azure Certified for IoT program. Device manufacturers want to be part of that program to make sure that you as a developer know that specific hardware support IoT Hub as a backend, as an ingestion service, and the Azure IoT Suite as a set of cloud services to build your end-to-end IoT solution. Last but not least, you can contribute to all these samples and SDKs. The libraries are provided in GitHub, and we accept external contributions. For now, it's public preview for the Azure IoT Hub, but soon we'll turn into GA, but your contribution is more than welcome. File issues, file bug, contribute code, and we'll see you on GitHub. Thank you.